Hello everyone, I'm Janmel and this is Data Communication 101. Today, we're going to discuss Operating System Interconnect, in other words, OSI layer. So, the OSI layer has 7 layers. For you to distinguish it easier, we would divide it into 2 groups. The application set, which is composed with application, presentation, session. The second is transport set, which composed of transport, network, data, and physical. All, what is an OSI model? It is a conceptual model that characterizes and standardizes the communication function of a computing system. The sequence is in descending order. I hope you enjoy. So, without further ado, let's start. The seventh layer is called the application layer. This is the layer that actually interacts with the operating system or application whenever the user chooses to transfer files, read messages, or perform other network-related activities. Next is presentation layer. It takes the data provided by the application layer and converts it into a standard format that the other layers can understand. When the presentation layer receives network's data from the session layer, it makes sure that the data is in proper format and once again convert it. The fifth layer is session layer. The session layer establishes, maintains, and ends communication with the receiving device. The fourth layer is transport layer. These layers handles transport functions such as a reliable or unreliable delivery of the data to the destination. On the sending computer, the transport layer is responsible for breaking the data into smaller packets so that if any packet is lost during transmission, the missing packets will be sent again. Missing packets are determined by acknowledgement from the remote device. When the remote device receives the packets at the receiving system, the transport layer will be responsible for opening all of the packets and reconstructing the original message. The third layer is network layer. Network layer is responsible for managing local addressing information in the packets and the delivery of those packets to the correct destination. Routers, which are special computers used to build the network, direct the data packet generated by network layer using information stored in the table known as routing table. The routing table is a list of available destinations that are stored in memory on the routers. The network layer is responsible for working with logical addresses. The logical addresses are used to uniquely identify a computer on the network, but at the same time, identify the network that system resides on. The logical address is used by network layer protocols to deliver the packets to the correct network. The second layer is data link layer. Resides above the physical layer and below the network layer. Data link layer is responsible for providing end-to-end validity of the data being transmitted. The data link layer is logically divided into 2 sublayers, the media access control sublayer and the logical link control sublayer. Last but not the least, the last layer is physical layer. Physical circuits are created on the physical layer of OSI model. Physical layers describe the electrical or optical signals used for communication. Physical layer of the OSI model is only concerned with the physical characteristic of electrical or optical signaling techniques, which includes the voltage of the electrical current used to transport the signal, the media type, twisted pair, coax cable, optical fiber, etc. Impedance characteristics, physical shape of the connector, synchronization, etc. The physical layer is limited to the processes needed to place the communication signals over the media and to receive signals coming from the media. The lower boundary of physical layers of the OSI model is physical connector attached to transmission media. Physical layers of OSI does not include the transmission media. Transmission media stays outside the scope of physical layer and are also referred to as layer 0 of OSI model. This is level of actual hardware. It defines the physical characteristic of the network such as connection, voltage levels, and timing. That concludes this week's video. If you have further question, clarification, or suggestion, just drop the comment below. I would like you to know your feedbacks about this video. If you like this and want more videos about data communication, kindly subscribe to this channel. If you want to know about me, just follow me on Twitter, John Mel Yee, double E, and in Facebook, John Mel Yee, single E. Thank you.